Hello everyone, this is Mohammad Ishman and I'm again with the new ICP dataset that is all about auto encoding. So let's start this tutorial. So first of all, we are just importing the libraries here. We are importing Keras, TensorFlow, and convolution 2D from the Keras and so on. And I'm using this dataset that is the built-in dataset in Keras dataset. Okay, moving ahead, we are just loading the dataset. As you know that this dataset is the built-in dataset, so it has already split trained dataset and the target dataset and the input dataset also. And after that, we just check the shape of our input train, input test, target train, target test. So here we can see that we have the input trend with 6,000 with 60,000 images with 28 by 28 in size. And if you go ahead, so here we are taking only 10,000 images from our data set. The reason is the power of the my machine is not enough to handle the 60,000 images. So I'm just using 10,000 images here as an input train and 1,000 images as an input test. And if we move ahead, so we just print out the top 10 images from our dataset. So you can see that these top 10 images here, and move and going further here. So I just print the shape of my input train and target test and target train. So here you can see that the 10,000 images of input train with 28 by 28 in size. The next step is to configure the model. So here I'm just taking image width and image height with what is the with equal to the size of input train, that is 28 by 28, and the batch size I'm taking 128, number of epoch I'm taking 100. So I'm just splitting my data set 70% in training and 20% in testing. So verbosity mean equal to 1 means so I need to print everything while training the data. So this is my latent dimension, which is since we have a 2-dimension image, so that's why I said to 2-dimension. And number tell 1 means that this image is grayscale. So I'm dealing with the grayscale image, that's why I set to 1. And I'm here just reshaping the data, and here I'm just normalizing the data like we did before, dividing each value with the 255 to make it in a range from 0 to 1. And after that, though there we are creating the encoder. So this is my I is my input shape, like the input shape we just mentioned above. So this is my first layer, convolution 2D layer with filter size 8. So it will learn 8 filters. And here we are using batch normalization. So batch normalization, it makes the artificial neural network make faster and steady. And after that, there's another layer with 16 filter, then again batch normalization. After that, we have a convolution layer of 32 with batch normalization. The reason I add 31 more layer with two more layers here with filter size 32 is like the first layer is just learn the edges and dots and something like that. And after that, the every pattern gets complex by every layer. So here in the final layer, we have a more complex and deeper patterns, so that needs to be learned. So that's why this is the reason I'm adding layer and adding and increasing the filter size. And the batch normalization is still doing the same. It just making the artificial neural network fast and making it steady and by reshaping or rescaling. And moving ahead, so this is my sigma function. This is my mu function. That is, I'm deciding with my model. Okay, so going ahead. So here, mu is my this output. The mu is my mean value, and there's another value with standard deviation. So after here, so we are just getting the convolution 2D shape. So that will be helpful to in making the decoder path. So here I'm just printing my convolution shape here. So it's 28 by 28 32. So one thing you have noticed here, I am using strides equal to 1 rather than 2. It's because well if I set strides equal to 2, so what will happen, let me show you here. So what will happen? So 28 will be divided by 2. So there will be output of 14. 14 will divided by 2 again. So there will be output of 7. And when 7 is divided by 2, so their output will be 3 point should be 3.5, but you know it's an integer value. So Python automatically round off to 4. So when this 4 went into the decoder path, so what will happen? So if I use the start is equal to 2 again in the decoder part 2. So 4 will multiply by 2. So it's 8. 8 multiplied by 2, it's 16. And 16 multiplied by 2 is 32. So you will see a difference between these sizes. So that's why I just changed my strides from 2 to 1. Okay. So after that, taking the shape. After we are just defining the sampling with reparameterization trick. So here is a sample of z with taking the argument, and in the argument we have mu and sigma, and we are just adding this layer to our model. So here, so if you go here, so you can see that we are using this lambda function for this. Moving ahead, we have a decoder. So decoder is doing just the opposite thing of the encoder. So it's getting the input with the latent dimension 2. And I'm just reshaping this to give the in. So basically, I'm just taking the size of final layer of encoder here. So the final layer comes here, then like for example, is 4, then 16, then 32. And I also add the convolution to the transpose layer here. The reason is like when I added the convolution duty with 32 size, so that layer's inputs need to be downsample. So here we need to add one more layer in order to downsample the final layer of the encoder path. Okay, so moving in, we just initiate the decoder. So here you can see that, so it's 28, 28. So size is same because I take the starts value to 1. And there you can see the decoder output, which is doing nothing. It just, I mean, with no filter size, it's just combining all the layers together. And moving ahead, we have a variable automatic encoder. So here, I'm just initiate my variable automatic auto encoder. So you can see that we have an encoder input, we have encoder, and we have decoder. And I just compiling my model with optimizer atom with loss binary cross entropy. And here I'm just training my decoder, sorry, autoencoder. So here you can see that I select the epochs as 100. So you can see that it's it's get trained with the validation accuracy of 1.19 and loss is 0.17. Here I'm just defining two function here, two method. So the one is for the Latin space, and the second one is for the decoded. So when I call this methods here, so you can see that this is a Latin sphere. It's just showing me, like for example, this one is 1. So and the light one is 2, and for example the 8 to 9, you can see that there's a yellow color. So this is the yellow, means it is the number between 8 to 9. So this is my latest one, and here you can see the output. So this is 7 9 4, this is 7 again, this is 9, this is 1, this is 6 8 5. So these number are generated from the actual data sets by using the auto encoder. Thank you so much for paying attention. And if you have any question, any concern, please feel free to reach to me, and you can comment on the Facebook video. Thank you so much.